Now let's talk about a few triangle properties in which trigonometric functions are included and how you can find out the sides or angles of any triangle. Let's say this is any triangle that I have. My angles are ABC and my side which is opposite to angle A is small a, side which is opposite to capital B is small b, and side which is opposite to opposite to capital C is small c. So there is a sine rule which is used for finding sides, which is A by sine A is equals to B by sine B is equals to C by sine C. Or let's say if we need to find out our angles, we can write it in reverse order as well. Now when we talk about our cosine rule, this is another rule. We write it down as, let's say if I need to find out my A side, so I can write it down as A square is equals to B square plus C square minus 2BC cos A. So A is the side which is opposite to cos A. So remember this thing, whenever we are finding A, that time we use the angle cos A. Let's say if I was to be finding side B, so I would write, my formula would become B square is equals to A square plus C square minus 2AC cos B. And let's say if I am finding my C side, so it would become C square is equals to A square plus B square minus 2AB cos C. So this is how I find it out. Now let's say if I need to find out my angle cos A, so simply I can write my cos A as B square plus C square minus A square upon 2BC. So this is used for finding angles. This is used for finding sides. Of course, it is the same formula. Just the thing is keeping things from here to there. It would make it for specifically for angle and specifically for side. Now one thing that I hope you all know, if I have a triangle, the sum of all sides, angles of all sides of a triangle is always equal to 180 degrees. So A plus B plus C is what we call as pi. Now if this is the case, now all these formulae would only work if I have a triangle, if my A plus B plus C is equals to pi. So remember this thing, do not use these formulas for any trigonometric function. These formulas would only be possible if I have a conditional identity, that is that I have a triangle A plus B plus C is equals to pi. Then only you can say sine 2A plus sine 2B plus sine 2C would be 4 sine A sine B sine C. Cos of 2A 2B 2C, their sum can be written as minus 1 minus 4 cos A cos B cos C. Sine A plus sine B plus sine C can be written as 4 cos A by 2 cos B by 2 cos C by 2. Cos A plus cos B plus cos C can be written as 1 minus 1 plus 4 sine A by 2 sine B by 2 sine C by 2. Similarly for tan, it can be written as tan A into tan B into tan C, and tan A by 2 tan B by 2 plus tan B by 2 tan C by 2 plus tan C by 2 tan A by 2. This gives us 1 always. Again, I am repeating this thing. All these formulas would only work if I have A plus B plus C is equals to pi. So do not use these formulas for any other trigonometric functions that you have. Let's look at this question. In a triangle ABC, so here they've mentioned us that it is a triangle. Cos A plus 2 cos B plus cos C is equals to 2. And the length of sides opposite to angles A and C are. So basically they've given us the value of small a, which is 3, and small c, which is 7. We need to find out cos A minus cos C. So first our motive would be to find out small b. So how are we going to find it out? Let's say this is our equation, plus 2 cos B plus cos C is equals to 2. So this is the equation that we have. So as we had studied in cosine rule, so we are going to replace this formula for each and every angle, and then I'll put the values of A and C, and then I'll find out whatever my B is. So this would become B square plus C square minus A square upon 2BC plus 2 times of A square plus C square minus B square upon 2AC, plus this would become A square plus B square minus C square upon 2AB. This is equals to 2. So now let me simply just put the values of A and C in this equation. So I would have C square would become 49. 49 minus 9 would give us 40 plus B square upon, here I would have 14B plus, here 2 and 2 would get cancelled out from each other. Here I would have A square, which is 3, 3 is a 9, 9 plus 49 would give us 58 minus B square upon A into C. So this would give us 21 plus, here I am going to have A square plus B square. So this would become 9. 9 minus 49 would give us minus 40. So this would become B square minus 40 divided by 2AB. So this would become 6B. This is equals to 2. Now from here I'll simply take the LCM. So what would be my LCM for 14, 21 and 6? Let me find it out here. For 14, 21 and 6. So I would have a 7, 2, 3 and 6. So I would have 2 and 3 here. So 7 2s are 14, 42. So this would be 42B would be my LCM. So here I would have 14 3s are. So this would become 120 plus 3B square. Plus here I would have 2B. So this would become 58 into 2, which would become 106B. Minus here I would have 2B. So this would become 2B cube. Plus here I am going to have 7 6 are 42. So I have 7B square. Minus 7 4s are 28. This is equals to 2. Now if I cross multiply, so I would be left with minus 2B cube. What are the B square coefficients? 3 and 7. So I would have a plus 10B square. Coefficients of B, I have 106 here, and then I would have plus 106 minus 84. So I would have 6 plus 6 12. 12 and 10 would give me 22. So here I would have plus 22B, and I would have minus 160 is equals to 0. So here I can take 2 common. I'll take minus 2 common, so that would be better. So I would have B cube minus 5B square minus 11B plus 80 is equals to 0. So this is the equation that I'm getting. Let me take this to the next page. So I have B cube minus 5B square minus 11B plus 80 is equals to 0. Now if you look at this equation carefully, if I put the value of B as 1, would it satisfy? No. That means I need to have values of B which are greater than 1. So of course you have to do this by hit and trial. You need to find out at least one factor by using hit and trial method only. So I'll use 4. Let's see if 4 satisfies. I would have B cube as 64. 64 minus 5 into 16, this would become 80, and 80 would cancel out amongst each other. Sorry, this one here, this would be 32. This would be 32B. I just made a little calculation mistake here. This would be 32B. So this would basically become 16B. So here I would have 16B. Now if I look at it carefully, can I take 4 as one of the factors? Yes. So B minus 4 would become one of my factors. And if B minus 4 is one of my factors, if I look at it carefully now I would have an equation which is on B square, and of course there wouldn't be any coefficient for B square. So simply it would become B minus 5. Another one would be B plus 4. This is equals to 0. So these are the 3 values that I'm getting. Now I have to check which value of B would be the correct for my equation. So either B can be 4, or B can be minus 4, or B can be 5. So first of all, B cannot be negative. So this is cancelled out. Of course, it is the length of the side of a triangle. It cannot be negative. When I talk about 4, so if my B is 4, that means my A is 3, my C is 7. And I hope you all know that this is a property in triangles, that sum of 2 sides should always be greater than the third side. So sum of 2 sides should always be greater than the third side. However, here you can see that A plus B gives us 7, but it is not greater than 7. It is equal to 7 but not greater than. That means this triangle can never be formed. So if this cannot be formed, so this is not possible, that means b is equals to 5 is the only possibility that I have. So I found out the only unknown side, which is b, which was 5. So here I have 3, 5 and 7. So this is my triangle. Now what is the value I need to find out? I need to find out cos A minus cos C. So let me just find it out. This would be b square plus c square minus a square upon 2bc minus, here I would have a square plus b square minus c square upon 2ab. Now let me just simply substitute the values. So b square plus c square, so 25 plus 49, this would give us 74 minus 9, 74 minus 9 would give us 65. So we would have 65 here divided by 2 times of b into c. So 10 into 7 would give us 70 minus, what are the values in this side? We would have 25 plus 9 minus 49. So we would have minus 40 and this would make it plus. So we would have 40 minus 25 and that would make it 515. So 15 divided by 2 3s are 6, 6 5s are 35. Sorry, 6 5s are 30. So this is the value that we are going to get. And now if we take LCM, this would become 210. So 65 into 3. 65 into 3 would give us 5 3s are 15, 6 3s are 18 plus 1 19. So we would have 195 plus 15 into 7. 15 into 7 would give us 105. So this would basically transform into 200, 300 by 210. So this and this gets cancelled out. This would cancel this out 10 times. This would cancel it out 3 times. So we have our answer as 10 by 7. This is our answer. So this is how you can use your triangle properties to solve any questions that have been given. Again, such questions are going to be lengthy and there are chances that you can make some calculation mistakes as well. So keep in mind that you need to solve this very carefully and very patiently, because these questions can be lengthy, but you need to solve it. As you can see, these questions are very simple and easy. Now talking about trigonometric solutions. Now this is the topic from which mostly questions are asked in JEE mains. So what if, let's say I have sine theta is equals to sine alpha. So I cannot say that my theta would be equal to alpha directly. So basically, of course, since my range of theta is from let's say 0 to infinity, that means I can say after every 2 pi repetition I would start getting the same value. And since it is sine, that means in my second quadrant also I would get the same repetitions. So that means if sine theta is equals to sine alpha, then my theta would be equal to n pi plus minus 1 to the power n alpha. So keep these things in mind. For cos theta also, it would be in this format. Tan theta, there is another one. Sine square theta, it is some other way. Cos square theta, it is other way. And tan square theta, it is other way. So for remembering all these, of course, you can see that for squares, all the ranges or the solutions are same. These are the general solutions which are same for all three. When we look at their simple 1 degree equation, so there we have a little bit of difference which you need to remember it. And alpha here, we call it as the principal angle. Let's look at a question for this so that it would become much easier for you. Let's say this is the question that we have. 2 sine cube alpha minus 7 sine square alpha plus 7 sine alpha. If you look at this equation carefully, if I take 2 to this other side, then I can take 2 common. I would have sine cube alpha minus 1. And on the other side, if I take 7 sine alpha common, I would have sine alpha plus minus 1, because I'm taking plus sine alpha common. So from there I can maybe try to find out something which is common from both these terms, and then it would give me my answer. So basically I am writing this down as 2 sine cube alpha minus 1. I'm taking minus 7 common, minus 7 sine alpha common. So here I would have sine alpha minus 1 is equals to 0. Now let me try to convert this sine cube alpha minus 1 into sine alpha minus 1. So this would become 2 times of sine alpha minus 1, and this would be multiplied by sine square alpha plus sine alpha plus 1 minus 7 alpha, 7 sine alpha, sorry, sine alpha minus 1 is equals to 0. So from here, if I take sine alpha minus 1 common from both these equations, so I would have sine alpha minus 1 whole into 2 times of sine square alpha plus 2 sine alpha plus 2, and here I would be left with minus 7 sine alpha is equals to 0. So from here I can say that one of my values for sine alpha would be 1. So my sine alpha can be 1. This is the first solution that I've gotten. Now let me solve for some other solution as well. If I look at this, this would become 2 sine alpha minus 7 sine alpha. So this would become minus 5 sine alpha. So basically the equation that I have, it is 2 sine square alpha minus 5 sine alpha plus 2 is equals to 0. Now if I find out the roots of this equation, so it would basically be 2 sine alpha minus 1, and what would be my other root? My other root would become sine alpha minus 2. So I can have two more values of sine alpha. So either my sine alpha is equals to half or my sine alpha is equals to 2. Of course sine alpha equals to 2 cannot be possible because sine's value ranges from minus 1 to 1. Now I have two values, sine alpha is equals to 1 and my other one is sine alpha is equals to half. So what have they given us in the question? They've told us that the number of values of alpha belongs to 0 to 2 pi. That means my alpha belongs from 0 to 2 pi. So only in this range, what are the values of sine for which I would get this answer? So for this, my alpha can only be pi by 2. Of course, if I try to write the general solution, which is theta is equals to n pi plus minus 1 to the power n alpha, if I try to write it down in this format, which is for sine theta, then of course I would still get just one value because my alpha would range in this value only. So it would be only pi by 2. However, when I look at this equation here, first one would be pi by 6. What would be the other one? I can also have 5 pi by 6. So in this equation, so basically I know that my alpha is pi by 6. So this would become n pi plus minus 1 to the power n pi by 6. If I put n as 0, so this would be pi by 6. If I put n as 1, so this would become pi minus pi by 6, which would give us 5 pi by 6, which is lying in our interval 0 to 2 pi. Now if I put n as 2, would it lie in this interval? No. So that means there are only 3 values of alpha that would satisfy this equation. So they had asked us to find out the number of values of alpha. So total values of alpha would be 3. These two and this one. So total values of alpha is equals to 3. So this is our answer. So this is how you solve questions of general equation. Of course, you have to remember all these trigonometric solution. Based on that, you would be able to write such equations. Put the values of n is equals to 0, then 1, then 2, then minus 1, then minus 2, and check whether it lies in the given interval or the condition from the question or not. If it lies, that means it is included in your answer. Let's look at one more question. Let s is equals to, this is the equation given to us. So in this question, what is the first step that we are going to take? First, we'll assume that at 9 to the power tan square x is equals to, let's say, a. I'll assume it to be a. So what is the equation that we would have? This is 9 to the power 1 minus tan square x. So I can write it down as 9 by 9 to the power tan square x. So it would become simply 9 by a plus a is equals to 10. So from here, what is the values that I'm going to get? 9 plus a square is equals to 10a. So I would have a square minus 10a plus 9 is equals to 0. So from here, what is the values of a that I get? 1 would be minus 9 and 1 would be minus 1. So my a is either equal to 9 or my a is equals to 1. So let me take this to the next page. That means my 9 to the power tan square x this is either equals to 1 or my 9 to the power tan square x, this value is equals to 9. So either of these two. So if this is the case, that means my tan square x would be equal to 0. And what are the values for which I would get tan square x to be 0? Of course, at x is equals to 0. If you look at the general solution as well for tan square x, it is theta is equals to n pi plus minus alpha. So I have my theta is equals to n pi plus minus alpha. Now what is the range given to us in the question? It is minus pi by 2 to pi by 2. That means if I put the value of n as 0, so here first of all my alpha is 0, sorry. So if I put n as 0, it would satisfy the condition. If I put n as 1, it wouldn't satisfy the condition because it would become pi or minus pi, and which is basically lying outside my domain. So x is equals to 0 is the only solution for this one. And at this point here I would have tan square x is equals to 1. That means my x is basically equals to pi by 4. Now what are the other values that would satisfy this? Of course, minus pi by 4. If you try to use this equation only, you would get minus pi by 4 as well. If I put n as minus 1, it would become minus 1 pi plus pi by 4. So basically we would get minus pi by 4 if we try to confine it in this range. So these are the values that I'm getting. Again, we have 3 values for x. Now what have they told us? That we need to find out beta is equals to summation x belongs to s tan square x by 3. So my s basically has the value 0, comma plus minus pi by 4. Now I need to find out summation tan square x by 3 by putting the values of x as 0, pi by 4 and minus pi by 4. So I would have tan square 0 plus tan square pi by 12 minus, sorry, plus tan square minus pi by 12. So of course, since I have a tan square, so this minus can be simply removed from here, because for one tan minus theta, I would get minus tan theta. For the other tan as well, I would have one more minus tan theta. So they would simply cancel out themselves and we would have a plus here only. So this is basically 2 times of tan square pi by 12. What is pi by 12? Pi by 12 is nothing but 15 degrees. That means I'm trying to find out tan square 15. So it is 2 minus root 3 whole square. So this can be written as 2 times of 4 minus 3, sorry, plus 3 minus 4 root 3. So this would become 7 2s are 14 minus 8 root 3. So this is what I'm getting my value as beta. So this is my beta. Now what have they told us? I need to find out 1 by 6 beta minus 14 whole square. So let me simply just replace the values. So this would become 1 by 6. Beta is 14 minus 8 root 3 minus 14 whole square. So 14 and 14 would cancel out amongst each other. This would be 1 by 6 into 8 and I would have a 3. So 3 2s are 2 4s are, I would have 8 4s are 32 as my answer. So again, this is the way of solving questions which are related to general solution. Again, you must always look at the range or the domain they've given us in the question. For example, here it was minus pi by 2 to pi by 2. And now you need to put the values in the trigonometric solution that you have of n as 1, 0, minus 1, whatever as integers. And then see what are the values that you are getting, and that would lie in the range or interval that has been given to us in the question. Based on that, you final out your values of x which are possible, and then you find out your answer. So that was all about this chapter. As I mentioned, this is a short chapter, mainly includes only formulas. I remember I have shown you a lot of formulas in this chapter, so I recommend you all to remember all those formulas, so you all could see, right, if you remember the formulas, solving the question becomes very easy. So that is why remember the formulas and then solve your questions.